Hello, everyone. Welcome to the second SolidWorks workshop of the two workshops hosted by UTDL. We are really glad that you all could make it over here. Our aim for this workshop is the assembly of parts as well as the rendering. So, before I dive into it, I would just like to hand over to Kyle, who is our tech executive, who will just give a brief overview of what UTDL is and what we do. Kyle,
Yeah,
too.
I'm Kyle, the technology director here at UTDL, accompanied by Yash and Shahir, who are technology officers at UTDL. We host, Shahir, introduce yourself.
Hello.
So we host a number of workshops, including SolidWorks, Fusion 360, Arduino, ANSYS, and Space Claim, and different simulations. And we'll have a 3D printing one as well at the end of our workshops. These workshops are to help people go from the digital to the physical world and aspect of design to get them ready for real world applications and to help them develop their skills for our design-a-thon, which we'll still be hosting, but online this year in the beginning weekends of February. So Yash, I'll hand it back to you and let's continue with SolidWorks Workshop number 2.
Okay, thank you so much, Kyle. So let's just start. Yeah, so this is the first assembly which we're going to be modeling today. It is the plumber block. So as you can see, we have two different views over here. So on the left is like a normal view. It has all the parts already. There's a geometric mate which has been added already. As you can see, this is the circular part is what we call the brasses. This is the base, and these are the nuts. And on your right, as you can see, this is like an exploded view of the assembly. Exploded view is like one of the many views which we use. So of which, this really helps us in analyzing the assembly and getting to know how many parts are there and like what all mates are involved in the assembly. So we're going to be learning about the exploded view feature later on during the course of the workshop. So I would just like to give a brief overview of what plumber block is and what's the exactly use of a plumber block. So this is like mainly used to provide like a support to the rotating shaft of a machine in order to transmit or absorb power, and with the help of bearings attached, which is fixed at the front of the brasses. So as you can see, using my pointer over here, the bearing is fixed over here, and it is used to provide that support. And the typical material from which this plumber block is made is either like cast iron or like cast steel. The next assembly which we're going to be looking at is before that, this is like the rendered model. So as you can see, it has got that realistic touch to it. I've added like certain material properties to it, and this is what it looks like. This is just an example. So we'll be learning about the rendering using PhotoView 360. So just stay tuned for that. The second assembly for today, which we're going to be modeling, is the pipe vise assembly. The similar pattern what we had earlier. On the left is like the fully assembled model. So this is like the base, and this is like the screw, and this is like the hand rod. And on your right is like an exploded view. This shows you where does the movable jaw sit exactly, and where does the screw go. So we'll be learning about this shortly. The next is like, what's the use of pipe vise? So pipe vise is like a sort of a plumbing tool which is used to hold any cylindrical object. So something like a tube or some like a cylindrical object very firmly in order to perform the process of either like the cutting using a cutting machine, or like a threading process during the manufacturing stage of the design process which usually happens in industries or like any other sector. And like the typical material which is used in to make a pipe wise model is the tempered steel or the cast iron. This is like another example of the rendered model. So there are certain, I've added like the material properties to it as well as the color, and this is what it looks like. I gave it a realistic touch to it. So let's just start. Before I dive into SolidWorks, I'm not sure if everyone has an access to their personal SolidWorks account on their own laptops. So U of T provides us with the remote access to the ECF desktop. So when you can go to this undergrad engineering website, and you can access this link, this URL, and when you click it, it will get downloaded over here. So I'll just show you how to actually access SolidWorks using the ECF desktop, so that it doesn't become a hassle for you to look for SolidWorks license and download it on your computer. So just click on it, connect it. It takes some time, but usually gets it done in like 5 or 7 minutes at the most. Yeah, so like usually when this page pops up, you need to enter your user ID as well as the password. And this page will show up then. Okay, now we look for the SolidWorks 2020 edition. Yeah, so just open it. And yeah, so the SolidWorks will open in like 2 minutes. I personally have a license to the SolidWorks account, so I'll be using that for this workshop. And if anyone else, you guys can use this. It will work perfectly fine. Just accept it and it will work for you. So I'll just close this window so that I just start with my assembly models. Okay, so when you when you open the SolidWorks software, this page shows up by default. And like last week, we covered how to actually design parts / models using various 2D tools like line, rectangle, and then we gave it a certain thickness and we converted those 2D sketches into 3-dimensional by using 3D commands like extrusion, extruded cut, revolve. And this time we will be using the parts and assembling them and adding that geometric relation, what we call the mates, in order to restrict the motion. And later on, when we are done with this assembly, in order to have like provide a good presentation of assembly model, we will be using rendering as a feature. So when you come over here, you see this blank document, press on the drop down menu, press new. And this document shows up. Last week, we worked on this part section, but this week we're going to be using this assembly section. Just click on it, press OK. I apologize for the delay, but it usually takes some time. Okay, so when you open the assembly interface, this section will show up by default. And when you open it, it will automatically ask for the components you want to assemble by default over here. So the first assembly which we will be performing is the plumber block. We'll start with the base model, which you see over here. Then we're going to be then we're going to be assembling the brosses, this cylindrical surface which will sit in this semicircular cut, and then we'll be adding the cap on top of it, and then the bolts, and then the screw. So I'll start with exporting the base part into the interface. So just press plumber block and press open over here. Yeah, so now you can see, you can just select anywhere and the part will be exported over here. By default, whenever you import the base part or any first part, the origin of the part is aligned with the origin of the SolidWorks graphical interface, and it is usually fixed. So like, you know, when you click on the model and when you try to move it by moving the mouse, it does not move and it shows that it cannot be moved. In order to move it, the feature is you come over here on the left feature tree, click on this plumber block, right click on it, and you will see this feature called float. Now the part is not fixed anymore and you can actually move the part around. So so it is a good convention, but not like, it's not mandatory that to mate the planes of the part with the planes of the SolidWorks, the default planes which SolidWorks provides. So we'll start by doing that. So in order to give a mate, we go over here in this assembly tab. We see this mate tab. We select it, and this tree shows up over here. So I'll just give a brief overview about the various kind of mates. So these are the standard mates which SolidWorks has: the coincident mate, the parallel, the perpendicular, tangent, concentric, lock. This is like the distance mate, the angular one. Then there are like various advanced mates as well as the mechanical mates. So we'll just be touching on a few of them, not all of them. So we'll start by giving a mate to the plane of the part with the plane of the SolidWorks interface. So you select the front plane of the part, and then you select the front plane of the interface, and you apply a coincident mate over here. Press confirm, confirm it, and there we go. Both the planes are now related by the mate feature. You fix it back over here. The next part which we're going to be exporting is this process, as you can see. So we do that. Come over here. You see this insert components, select it, and the box, this dialog window automatically pops up. So we'll start with the process. Okay, so as you can see, I want this protruding circular surface to go into that hole which you see over here in the semicircular cut. So as you can see, the part right now is not aligned to that. So, you know, just to have a better command, so what we can do is we can actually align it in that way so that it becomes convenient for us. In order to do that, there's this rotational dialog box over here. So there's X, Y, and Z coordinates, and you can rotate the part accordingly to that. So I press the Y coordinate, and then I use the Z coordinate. Yeah, and now as you see, this part is supposed to sit on it over here like that. So just leave it, just select it and leave it over here. So it's gone below. So it's this kind of thing which happens to you. So just select the part and just drag it outside. Now, so in order to perform the mate for these two parts, what I would like to do, I would add a relation using the axis or the temporary axis of the part. So as you can see, the axes are not visible right now. So in order to make it visible, go to this command window at the top. There's file, edit, view. Go to the view. Go to this hide/show tab over here. Select the axis. Select this temporary axis. And as you can see, all these axes have started, they all are visible now. These axes come into play when you're actually making the part over here, when you're actually sketching it in the 2D interface and then you're actually converting it into 3-dimensional. That's when these axes come into play. So I'll be using these in order to perform the mate and to fix it over here. So select the mate tab again over here and just drag it around. So how you drag it is you select the mouse wheel and you hold it and you just drag it to whichever direction you want it to. And you see this vertical axis, I would select that. And you see over here, it just shows whichever axis or any part I've selected. So and under the mate selections tab, you see axis at brushes 1 has been selected. And then I come over here, I zoom in using the mouse wheel again, and I pull it towards yourself, like then it will zoom in like this. And I select this vertical axis of the whole. And as soon as I do that, both the parts get aligned to each other using the coincident mate. So they've been aligned. So both the axes are like aligned now, and their movement will happen only in that particular axis. So press confirm over here. And as you see, I try to move the part. It will just move in that particular plane. Yeah, and now what I do, I select this inner circular surface and I want this to sit over here. So I select this. Yeah, I press confirm. And in order to ensure that the mates have been successful, and just keep one important thing in mind, that the parts our aim is to restrict the motion between the parts. So just always keep one thing in mind, just keep a check that the part is not moving and it is fixed to that place. So how to do that? Just select the part and just try to move your mouse. And as you can see, the part is locked. It's not moving. So that is perfect. So we press confirm over here. And now we don't need these axes anymore. So just go over here, go back to the view tab over here, go to hide/show tab and select back the axis as well as the temporary axis, and they've all just become invisible now. The next part which we will be exporting is this cap part, and it will sit on top of the brushes part. So let's just export that, go back to this insert components again, select the cap over here. Yeah, and we want it to sit on top of it like that. So let's just leave it over here. Yeah, and go to the mates tab again. And now I want this bottom surface of the cap to sit on top of this base part. So I select this bottom surface and I select this top surface and I apply the coincident mate. So now both the parts, both the surfaces are touching each other, and press confirm. As you can see, it's not sitting exactly in the middle. I don't want that. What I want is this circular hole should be aligned with the hole of this. So how I do that is I apply the concentric mate, as you can see over here. I select this, I'll select the inner circular surface. Make sure, like, when I selected it, it showed the face feature which I've selected. Make sure that you don't select any edges, like, it shows edge 1 over here or any other part. So like, which shows the cap. I want this particular surface to be concentric with this circular surface. So select this circular part and then this, and apply the concentric mate as you can see over here. Press confirm. And just to ensure that the part is locked and it's not moving, I would just test it. Like you can see, it's fixed on the, it's not fixed on the opposite side. So what I do is I apply the similar mates over here in order to fix the part. Select the bottom surface over here, select the top surface, coincident, yeah. And then I apply the concentric mate again, select the inner hole surface, select this inner hole surface, yeah. And now they are coincident and the part is locked now. Yeah, as you can see, we are almost reaching our final assembly model. The only parts which we are left with are the bolts as well as the screw which holds all the parts together. So the next thing which we're going to be importing, which we're going to be exporting into our SolidWorks interface are these bolts. So we'll select the insert components again. Go with the nut over here. Yeah, and I wanted to sit horizontally on the top of this surface. So I don't want it to sit like vertically over here. So what I do is I use the rotational toolbar over here again in order to align it that way. Yeah, perfect. I do that. I leave it over here. And I again go to insert components, select the lock nut, open it, change the alignment. Yeah, I want something like this. Just leave it on the side over here because this lock nut will sit on top of this nut over here. So what I want right now is I want this bottom surface to sit on top of this, the top surface of the cap, and as well as this circular whole surface should be concentric with this whole surface over here. So the two mates which we will be using are the concentric and the coincident mates. So go to the mate tab again, select the bottom surface. Just give me a second, I think for better view. Yeah, select the bottom surface over here, select this surface, and we apply the coincident mate, and the two parts are touching, the surfaces are touching. Press confirm, and now to make the two whole surfaces concentric, select the inner surface like this and select this, and the concentric mate is applied automatically. Press confirm, press confirm. And the similar thing we do for the lock nut. Go to the mates tab again. Yeah, and select this bottom surface, select the top surface. Yeah, press confirm, and I want it to be concentric. Select the inner surface and select the inner surface of this hole, and they're concentric. Yeah, and the next thing is the next thing to support all our parts of the assembly, we need to export this screw over here, which will hold them firmly. So let's just do that. Export the bolt over here. Yeah, and my aim is that the bolt goes through, there's a hole as you can see over here, all the way up to the top, and it holds the parts together. So let's just leave it over here. Yeah, and what I will do, I go back to the mate tab again. Select this circular extended length or the surface of the screw, and then select this inner circular hole. Make sure, again, I would like to reiterate the fact that don't select the edges, you know, in order like to avoid unnecessary mates. Don't select the edges, but try to select the inner surface. How you do that? You come over here, you select this surface and it gets aligned. So there's a concentric mate which I've added, and now the screw and the base, the body, they are concentric to each other. Now what I want the screw to go all the way up there. So how I do that is I select the top surface of the head of the screw, and then I want it to go all the way up to this inner surface. So I select that and I apply the coincident mate, and as you see, it is gone all the way up till there. Press confirm again. Now, I would like to show you one thing. So just zoom in, and as you can see, the bolts are moving, they're not fixed. And when you come down over here, you see even the head of the screw is moving, it's not completely fixed. So we don't want that. We want assembly to be locked in place and fully defined. So in order to do that, I select the mate tab again. Yeah, clear this section. I select this face, and then I select this face, and I apply the parallel mate. And as you can see, press confirm over here and select this face again, and select the face of the lock nut and select the face of this nut and make it parallel. Sorry, and make it parallel and press confirm. What this parallel mate exactly does do is it makes both the surfaces, so the front surface of this and the front surface of this nut parallel to each other. So there's a relation which has been added which ensures that these two surfaces are parallel to each other now. The same thing has happened with the lock nut which has been placed on the top. Now when you try moving it, it's fixed in place, and you can see that the part is fully defined, it cannot be moved. And at the bottom of it, this time, in order to lock the head in its place, we will be using this common mate called like the lock feature. So how I do that, I go to the mate tab again. Yeah, I select this surface of the head of the screw, and I select this inner surface, and I use this lock icon. You can see it locks the two components. You can see this lock icon over here. Just select it and press confirm. Yeah, and so the head of the screw is fixed now. You cannot move it. The assembly is almost done, but the only missing thing is that it needs to be there. Like I need to have the similar features on the opposite side. So now we have two options. Either we can export all the parts again on the opposite side and apply those mates, or a time a way to, in order to save time, what we can use this feature called the mirror feature in the assembly. What it does is that it will replicate all these parts on the opposite side with all the mates which I've added over here. So it will just be like a replica of all the features as well as these parts. So how I do that is, first I look for the central plane of this assembly. So look for the central plane over here. Yeah, I can see that the right plane is correct, selected. Now come over here to this linear component pattern, select the drop down menu and come all the way down at the bottom. You can see there's this mirror components, select it, and you will see this feature tree on your left. So the mirror plane has already been selected because I had selected it earlier, the right plane. Now the components to mirror, I select the nuts and the screw. So select the nut first, then the lock nut, double click it, it shows over here, then the bolt, press confirm. And as you can see, it has been replicated to the opposite side with all the relations. So in order to, just ensure that, just check if, if anything is moving. No, everything is fixed. So with this, we come to the end of the first assembly, the plumber block. So this is what it looks like. We've added all the necessary mates amongst the parts, and we've made sure that none of the parts are moving and all the parts are related to each other, and we've restricted the motion. And now I would like to move on to our next assembly for today, which is the pipe vise. As you can see, we'll start with the base part over here. And then we'll start with the screw, which will go over here, which will go all the way down in this whole surface with the movable jaw, and it will go move up and down. And you can imagine, right, like, just try to visualize it, that, something which is the movable jaw tries to hold the pipe firmly and the cut is made. So let's just start by exporting this base part first. Sorry for that. Let's just start. So now this assembly has been done. Now, in order to open a new assembly page, or we follow the similar procedure, is that we go over here, select this blank document, press OK. Yeah, so the new page has automatically opened itself, and by default, the page will show up for asking us to export the parts. So before I start my second assembly, if any one of you has any doubts or anything which you found a little, like, or something which you couldn't understand, you can just ask me, or you can just drop an email to our tech mail ID or to my personal ID, which I'll be showing in the end. And you can just clarify any doubts you have, and I'll be more than happy to help you. So yeah, we go to the pipe vise folder over here, select the base part, which we'll be doing. Yeah, just leave it over here. And by default, as I said earlier, it is fixed, and the origin of this part is aligned with the origin of the Solidworks interface. So I don't want that. So just try to float it. And what I said earlier, so, just a useful tip is that, just try to align the planes of the model with the default planes of the Solidworks interface. So in order to do that, just select the mate tab again. Go to the open this drop down tree of this the base part. Select the front plane, yeah, and select the front plane of the Solidworks interface. We apply the coincident mate and press confirm. Press confirm. We fix it again, and now we will start by exporting this screw over here. So yeah, so go to the insert, select the insert components tab again, select screw. Now, as you can see, I don't want it to go horizontally. I want it to go vertically at the top through that whole surface. So in order to do that, come over here at the bottom. As you can see, there's a rotational tool bar. So just, fix the orientation of the part. Yeah. Perfect. Yeah, I want it to go at the top over here. So just leave it over here. It's just a good way, if you can orient the part in whatever direction you're trying to apply the mate. Now, I export another component, which is the movable jaw, which will be fixed at the bottom of this, of the screw, as you can see. So just drop it over here. Now I will add a mate mate between the screw rod over here and this movable jaw. Select the mate tab. And for this relation, my aim is that the screw gets fixed into this movable jaw. How I do that is I select this conical surface. You can see, select it. And as you can see over here, it just displays the face 1. I would like to reiterate against that, try avoiding that, try avoiding the edges over here, selecting the edges and everything to avoid unnecessary mates. And, in order to keep a check on it, like you've selected this, as you can see on your left, it's showing that you've selected the edge. I don't want that. So what you do, you select it, you either use delete or clear selections. Come back over here, select this revolve feature of the conical face and select this inner hole surface. Yeah, and now the screw rod and the movable jaw are concentric to each other. The concentric mate, I've added the concentric mate to it, press confirm. And now they're restricted to move in that particular plane. So like, select this part, take it up and see, it's restricted to move over on that. So like, as you can see, when I try to bring it down, it's going all the way through the part. That doesn't happen in real life. So what I do now is I want this particular surface, to touch this surface and this part to go all the way down and gets fixed. So how I do that, I select this surface, I select the top face of the movable jaw, and as you see, it gets dragged down to the bottom. And now when you try moving the jaw, both the parts will move together because now there's been a mate which has been added which restricts that movement. So press confirm. Now what I want this, the screw rod and the movable jaw to get fixed over here through this whole surface. How I do that? I select the mate tab. Yeah, and one mistake which many of us do is that we look for the cylindrical surface. We want this surface to go through over here. So we select this face and we select this inner surface. So I do that. You see, I selected the edge. It will lead to some problems later on during the process. So I don't want that. So just drag it outside. Yeah, just cancel it, go back to the mate tab again. I select this top circular face over here. It's showing the face has been selected. Perfect, I want that. And now I select this inner hole surface. Yeah, the concentric mate has been added, so both the surfaces are touching and now they've been restricted to move along this plane. Press confirm over here and you try to move it. You see now it's just moving along that plane. It's not going out, or it's not coming towards towards yourself. Like if you try to move it, press confirm. Okay, now as you can see, when I'm trying to bring it all the way up to the top, the part is actually going through the base part. That doesn't happen. I need to avoid that. I need to make sure that this movable jaw doesn't come all the way up to the top and reach a certain distance. And when I bring it to the down, it doesn't go all the way like this. How I do that is there's this mate, what we call the limit distance, which is an advanced mate. So what it does, it actually gives like a certain distance in which this part will move, and we put in some constraints which I'll just show you. Go to the mates tab. We won't be using the standard mates. Come to this advanced mates drop down menu, and as you see, there are various kind of advanced mates. So there's this profile center, there's this symmetric mate. So what symmetric mate does is that it adds a symmetry between the various parts. So we can add we can make the various planes or the surfaces of the parts symmetric by using this mate. Then there's this width mate. We can add a width to a certain part, and there's this path mate. So what I'll be using is this limit distance mate. You select it, and I put in the distance as 100 meters. So 100 meters. And over here, there are two constraints which we need to put. So first is the maximum value it will go up to, and as well as the minimum value. So the maximum value I want is 100, and the minimum I want is 10 millimeters. And now over here, what I want is, I don't want the jaw, I want this face of the jaw to not cross through this part. So what I do for the mate selection, I select this top surface and I select the top face of the movable jaw. Yeah, and now it's been added. This is done, so just confirm it. Now when you try to bring it up, you see it doesn't go all the way up, so it doesn't cross the part, and this looks more realistic. Like, so when I take it all the way to the top, it doesn't cross it. When you bring it down, the next part which we'll be exporting is the hand rod, which actually gives us support while we are actually trying to make a good grip to the part while holding it. So here's the hand rod which we'll be exporting. So go to the insert components tab again, go to the hand rod, open it. Yeah, and I wanted to go through this hole, so just leave it, just drop it over here. And I want this hand rod to go through this circular hole over here. So how I do that? I go to the mate tab, I select the cylindrical surface, and then I select this inner hole surface, and I apply a concentric mate to it. So, you know, both the surfaces becomes concentric to each other. Confirm it. And as you can see, yeah, sorry, just to make it more visible for you guys. Yeah, okay, so as you can see, this is what will be used. So as you go down, you can use this, press confirm, and you know, you can just play around with this. So as you can see, it's just crossing that. I'll just show you how to avoid that. So the last part of this assembly, what we'll be doing is we'll be exporting these caps in order to avoid for the hand rod to fall, like, you know, just to obstruct it from actually just going through that hole and falling. So we'll be exporting the cap. So we want it on either side. So I export this, and okay, never mind, just give me a second. I have like a backup file. I'll be using that. Yeah, perfect. Okay, so I drop it over here, and I again go back to the insert components. I again want another cap on the opposite side. Select it again, bring it over here. Okay, and what I want this circular hole, so like the circular hole surface, to go through this protruding surface which is coming out, and to touch this surface. I don't want it to go all the way over here. So how I do that? I go to the mate tab again, select the inner hole surface. Make sure again that you're selecting the face. Just keep a check on your left that you select. Just see over here under the mate selections tab that you've selected the right face. Then you click on this circular hole surface. Yeah, and as you can see, what has happened is that the opposite end has been mated. I don't want that. I don't want that. I want this particular hole surface to mate with that. So how I do that? You see all these various mates are there. come over here. You see these two opposite direction arrows. We call this the flip mate alignment. So it will just flip the part to the opposite side. So just select it. And as you see now, it has just gone through this. It has just flipped its direction. So you can use that and there's a concentric mate which has been added, and now both these parts are concentric to each other. Press confirm. And now when you try to move the part, you see now it's restricted to move in that plane. And now I want these two surfaces. I want this to go through this and to be locked in that position. So how I do that? I select this surface and then I select this surface. Yeah, and now press confirm. And I've added a coincident mate to it. Now you try to move it. You see, now it's not going through this, but it's going through this gap. So press confirm. I do the same on the opposite side. Select the mate tab again. Come over here. You select the inner hole surface. You select this surface. The concentric mate has been added. Press confirm. So you see the part is actually going through the cap. I don't want that to happen. So just drag it outside. Again, I would like to reiterate it. So if you want to drag a part, so just select it and hold your left mouse key and just drag it outside. You see, now it's restricted to that plane. So it's just moving around in that particular plane. It's not going anywhere else. So I select this face again. And I select this face again. And you see now the coincident mate has been added. Press confirm. Confirm again. So the assembly is almost done, like so. But the issue which arises now is that, you know, as you can see, this part particularly, you see, it goes all the way through the part. I don't want that. It doesn't happen in real life. So I don't want that to happen over here. I want to have a realistic assembly. So how to avoid that? We will be again using the limit distance mate. So go back to the mate tab over here, not these standard mates. Come down here. As you can see, the advanced mates option, select the drop down menu, go to this limit distance mate. There's this angular mate, limit angle mate, which is not in the scope for this workshop. We'll be using this limit distance mate. Select it, put in the distance as 50 millimeters. The maximum value should be 50 millimeters and the minimum should be 5 millimeters. And now we'll select the faces. So how I do that is I select this face. Yeah, I select this particular face. The mate has been pressed confirm and press confirm again. Yeah, and now when I try to move it, you see, it will go up to a maximum of 100 millimeters and a minimum of 5 millimeters. So it won't go beyond that, as you can see. So this will really help me. I'll just give you a good view of the assembly model. So if you want to drag the entire assembly like this, so this is just a basic command again. Hold down your control key and hold your mouse wheel and you can just drag it around over here. So, you know, when I try to bring it up, bring it down like this, as you see, you know, the similar issues happening over here. So I'll have to add a limit distance mate again on this surface to avoid that particular issue. Go to the mate tab again and go to the advanced mate, select the distance mate again, put in 50 millimeters, put this as 5 millimeters, and come up here on this blue rectangular box under the mate selection, select it, and you can select this surface of the screw rod. Just remember this surface, as you can see, And you know, when you hover around the surface, this orange borderline starts to show. So you select the surface and then you select this surface. Yeah, so the mate has been added. Press confirm over here. Okay, so now when I try to bring it down, you see it just gets stopped. So the assembly is completed now. And as you can see, you can just play around with the assembly. This is what it looks like. So, you know, you bring it down using these, you can hold it, you can just bring it down like this. Yeah, so with this, we come to the end of this assembly model. So the next thing is the SolidWorks has a built-in feature of this called the design library, which offers various mechanical tools like gears, bearings, or you know the screws, bolts. So you know, if you want to, if you're performing an assembly, and if you need a particular kind of screw or a bolt, you can actually use the design tool library to actually get access to the part. So I'll just show you briefly how to do that. You see this left toolbar over on the right, you see this vertical toolbar. So there are these various 3D experience marketplace, SolidWorks resources. You come to the third icon, you see the design library, select it. And usually, like for me, this page displays for me, but for like people who've actually opened it, there'll be like an add-in option which shows up. So you select the add-in feature, add-in option, and the design library will be added to your SolidWorks interface. So as you can see, the toolbox, it has, firstly, it will show us the various dimensions or like the metric system we want to work in with. So there are various options available like the ANSI, inch, AS, CISC, IS. So for this workshop, we are concerned with the ANSI metric one. So just select it. And now, so the various tools, like, you know, there are these bearings, bolts and screws, nuts, O-rings, power transmission, which are the gears, washers. So I select the bolts and screws. So again, there are these various, sorry. So there are these various tools like the hex head, the machine screws, the self-tapping screws. So I'll go for the hex head one. And there are these various hex head screws with the different dimensions. So just select it, right click it. So if you want to insert the exact similar part to the assembly, you can do that. Select it, right click on it and just select the insert into assembly option. And as you see, the part is over here. Yeah, just so on the right, you can actually configure the component. So like, you know, you can actually change the various features. So, you know, something like you can change the size, you can make it M10, or, you know, the finishing of it, if you want like a washer face, or you want like a shampoo face. So you can have that. The length of the cylindrical surface, if you want it, you know, like 40, you can have that. It gets increased. And the thread display, so like over here, if this is like the schematic which has multiple threads, if I don't want that, if I want the cosmetic one, I can have that, which is like a very light threads. Or if I want a simplified version, I don't want any threads, so you can have that. And this is the configuration name, which really helps us, you know, later on when we're trying to actually recollect all the parts which have been used. So just press confirm. And as you can see, this bolt has been added, and you can actually use this in your assembly. And according to the clients or like any of your part requirement, you can actually import the various tools, bolts, or anything, bearings. There's like ball bearings, roller bearings, machine screws. You can actually import any of it into your assembly, and you can actually perform the mates again and just fix it into your assembly. So I just delete this part. Okay, so in our modeling process, so we start with the 2D with the analyzing the 2D drawings. We start with the 2D sketching, then we convert those 2D sketches into 3-dimensional, and we add those 3D commands like extrusion and everything. We make parts, and then in assembly, what happens, as you saw in this workshop, we assemble the multiple parts together by adding various geometric mates to it. And then the third stage which comes is how do you actually present the assembly which you performed over here in, like, you know, if you want to present it to a third person, or, you know, later on in your career, if you want to present it to an executive, or like if you're actually giving a workshop, how you do that? So there are actually two options. So there's this exploded view, and then there is the rendering using Photo View 360 feature. So firstly, I'll be going through the exploded view feature. So you can find the exploded view feature in the assembly tab. You come all the way to the right. You see this exploded view feature, select it, and this feature tree starts showing on the left. So these are like the explode steps which will just happen. And for the part selected, I want this screw rod. And when you select it, there are these coordinates which just starts displays. So I want it to go I want to go little up. You can actually give it a distance. So this is like, I wanted to give it a distance of 105 millimeters. Yeah, I do that. And then I select this. I've select this screw rod to go with that. Then I select these caps. Yeah, so you see these on the explode steps command. This is just showing the parts which, you know, I've added the exploded view. So over here, you come to the down over here, press done. So the first exploded view has been done, which consists of the screw rod, the hand rod, as well as both the caps. Now what I would like to do, I would like to move this movable jaw up all the way here. So I select this movable jaw. This circular coordinate system again starts displaying. Select the Y coordinate, bring it all the way up to the top like this. Yeah, so the movable jaw in this part line I just selected, and this is the explode step 2. And the distance, you can give it any distance you want. Right now, I'm just giving any random dimension just for the clear demonstration of this particular feature, exploded view. Press done. And the third is I would like to move this base part. So I try to move it a bit down. Yeah. So this is the exploded step 3. Press done. And when you press confirm, as you can see, this has been done. The exploded view. So you can take a snapshot of this, and you can actually, you know, use this. And this actually really helps in getting to know and analyzing the assembly and getting to know what all parts were involved while performing this assembly and where exactly does this part sit in the assembly. So we've done this with the pipe vise. I'll show you with the plumber block how we go back to the exploded view again, go to the assembly tab, go back to this exploded view again. So firstly, I would like these bolts to go up. So what I do, I select this. Yeah, I make it go all the way up. I select this. I give it a dimension of, say, 45 millimeters, just any random dimension you can give. Yeah, so 45 millimeters, or if you want, you can actually go more up. So this is like 67 millimeters. Press done. So the first exploded step has been done. So the second thing, what I want to do is I want to move these screws downwards. So I select it, bring it all the way down like this. Yeah, and I select this as well. And when you select the opposite screw, it automatically goes down to that particular direction. And at the same time to that particular distance. So the exploded step 2 has been done. Press done over here. Now I would want to move this cap upwards. Select this. This again, this circular orange coordinate system shows up. Select this y coordinate, move it upwards. Yeah, press confirm. Oh. So as you can see, this is like the exploded view of the plumber block. So like imagine if like, you know, if I'm trying to analyze using the exploded view, so these screws go all the way through this whole surface and the bolts sit on the top of the cap, and the cap goes through this this space over here. So this really comes into handy when you actually need to present your model. So now if I want to get, you know, rid of this exploded view, you select the exploded view again, and it comes back to the normal view. The second feature which I would like to talk about is the rendering. So what rendering does, it like, you know, you can, so there are like two options to rendering. First is like a very direct feature, which I will just show you. And the second is adding those material properties as well as color to the rendering part. So for me, I already have the render tools, but like, you know, if it does not show for you, so go to this toolbar up over here, go to the tools tab, and in the drop down menu, come to this add ins options, select it, and you will see these various, sorry, I'm just waiting for it to show up. Yeah, so as you can see, there are these various SolidWorks add-ins which you can do. So just select this empty square box and press confirm. So like select it, press OK. Yeah, so you'll see over here that these render tools have been added, and this integrated, and this photo view 360 over here. So now if someone like, you know, if any of you cannot find this render tools option over here, just come over this empty space, right click on it, go to toolbars and look for the render tools over here. This is over here, select it, and the render tool has been added. It will be added over here, and you'll see all these options. Okay, now there are these various options for like rendering. So first is the edit appearance. So in order to give it a certain color to the assembly, we select it. Yeah, so for the color, we can give it like so just select the parts, or you can select the entire assembly from here. So this is like brownish, so you can have that. Or if you want to change the color, like, you know, if you want to keep it a little lighter, so we'll go for, actually I'll go for this brown color only for now. Press confirm. So this brown color has been added. And now, so if you want to edit the scene, so like the background scene, as you can see, it is completely white over here. How I did that is, you see this horizontal various tools over here. You see this black and white like a surface, and on top of that there's this colorful ball which sits. So select this apply scene, press this drop down menu. So the 3.5 by default is already selected. I don't want that. I want a plain white background scene. I select that, and now you see there's this plain white scene which is showing now. Okay, so I can select this edit scene, and I can actually add like a background scene to my model. So something like, you know, you can have like you select this warm kitchen. You can, so there's this warm kitchen which shows up. You can double click it, or you can actually drag it, which will happen like over here. Yeah, so if you don't want that, if you, so what I'll you can just again drag it over here, you can just play around with it, and whichever you like, you can actually go for it. I would go for this, nope, not this. Yeah, I'll go for this background studio room, press confirm over here. Okay, now comes the rendering part using PhotoView 360. So we have two options over here. If you want like a quick rendering of the part, like I haven't added the material properties, so there's not like a material to this. If you want a quick preview of this, you can actually select this integrated preview option, and it will actually give you like a rendered preview, a quick rendered preview without material properties, and you can actually take a screenshot or a snapshot of the rendered model and you can save it, but without the material properties, as I said earlier. So rendering usually takes some time because it gives you that very clear, that realistic image. So it just takes some bit of a time. So just please bear with me for that. Yeah, see, now it's getting, the rendering has been added. So this is what you get. So you can just move around the part and you can actually zoom in. So yeah, so this is what you get, like, a clear picture. You can actually move it around, or you can zoom in. Okay, so that was the integrated preview option. And now let's give the assembly, like let's add a material to it. So how I do that, I come over here on this vertical toolbar, come to this colorful ball, select this appearances, scenes, and decals option, select it, go all the way to the top, and you will see there's this plastic metal over here. So for the metal, we have various options like steel, chrome, aluminum, bronze, brass, copper, nickel, everything. As I mentioned in in the PowerPoint slides at the beginning of the workshop, the material usually is like iron or steel. So what I do is I add this cast iron, I hold it and I bring it here, I drop it over here, and I will get an option to actually, add the cast iron material to the just the face, the extruded face, or like the cut, or like the body of this particular, or like the entire assembly. I want this to be applied to the entire assembly. I do that. The material has been added. Now I would like to, have like look at it, like have like a final render to it. So come over here, you see this final render option, select it, and now it will show you the final render with all the properties added. It just takes a lot of time because of the materials and everything added. So imagine if you're like working on a very on an assembly which has a lot of parts. So and the amount of appearances as well as the material you add to your assembly, it will take more time because it tries to give you a very clear cut picture of the model, of the like the rendered model. As you can see, this is happening over here. Yeah, it takes some time to actually process the model, and to actually make a rendering of it. It can take, like sometime it can take up to like 2 or 3 minutes or 5 minutes, or like, sometimes like, later on, if you'll be working on a complicated assembly, it can take up to several hours to get you that rendered model image. So as you can see, it has started showing over here, the cast iron, it's blue in color. This is what you get. And the background, what I added, the studio room, it's there. Yeah, so you see, this is like a very good presentation of the assembly model which I've done, and you can actually present it, or like, you can actually use this as this thing as for like, future purposes. And I would like to show you another example which I must have done in the past. Something like this. You see, this is just like the silvery version. So you can zoom in by just using your mouse wheel, but you cannot rotate the part over here. And look at this. This is with the different scene, background scene, as well as the different material, as well as with the different colors. And you see, this is what it looks like. There's that shiny appearance to it. Okay, and now lastly, I would like to show you with the pipe-wise one. Yeah, what I do, I come back to this appearance scene decals option, select it. Yeah, this time I would like to add, you can add any material you want. So I can go for steel, and I can go for polished steel over here. Yeah, and this again, this horizontal tab opens up. I want the material to be applied to the entire assembly. So you select this assembly part. It's not been added to here, so just wait. Yeah, perfect. Okay. Now I'll again add the part because it was not added to the screw and the hand rods. If this kind of issue occurs, like, you're not being able to add to the entire assembly at once, you can just drag it and add it to the various parts over here. Yeah, so it has been added. Lastly, these caps. Okay, perfect. So the polished steel material has been added. So I go back to the render tools over here. I edit the scene, the background scene, actually the color. I would go for the default grayish color, which was there already. And this time I would like to, I would use a different background scene to just show you how does it look like in the final rendering of it. You press confirm over here. Yeah, and the similar thing what I talked about earlier, if you want like a quick preview without material properties, you can just use the integrated preview. I would like to show you the final render of this assembly model. So just select it. It will take some time to actually just analyze the model and come up with the rendered picture. Okay. See, as you see, this window pops up and you can actually, sorry, yeah. So you can actually see it started showing. Just take some time to actually add those effects, add those various effects to the model. Okay, we are almost there. We can see the rendered assembly model. Okay, see, we can start seeing the assembly model over here. It's almost done. Yeah, as you can see, the part is, you hear that sound? That's what signifies that the rendering has been completed. So over here, you see, this is the polished steel pipe vise assembly. And you see this shiny, this is the polished, you added that material. And the background seems a little different over here because I changed it earlier. And I would just like to show you another few of the renderings which I did in the past. You see, this had the similar background, but the material as well as the color was different. So you see, this is like some other polished material, and the color, this is like a brownish color, which has been added. So you can use this, so you can actually save the image by using the save image option over here. You can save your rendering models, and you can actually use it later on. And you see this preview window over here. If you want to align it in a particular direction, so you can actually move it around. If you want to align it at the center, and it automatically gets shifted in this preview window. So like if I want to shift it around over here like this, it will shift over here. So whichever orientation, or like whichever particular way you want it to show, and you can do that by using this. And you can save the preview image from here. And yes, so with this, we come to the end of the second SolidWorks workshop, the assembly and the rendering. Hope you guys learned something new after watching this, after attending this workshop. We have a lot of exciting workshops coming up. So just stay tuned and just follow us on all the social media platforms, and just stay tuned for the workshops. And if you have any questions, just drop me an email. I'll just show you just give me a second. I apologize for the delay. Yeah, so it's taking some time, sorry for that. Yeah, so if you have any doubts or queries, or anything about the workshops, or something which you couldn't understand, just drop us an email at this, or yeah. So, and my team and I will be more than happy to help you out. Thank you so much for attending this workshop. Hope you guys have a great evening. Thank you so much.